My name is Barry Schnurr. I'm the CEO of David Schnurr Associates. It's my honor to introduce Ryan Balco with Nordson Medical in Minnesota, a biomedical engineer at Fast Forward, Invention Medical, where he served as engineering manager before taking on a commercial role. Ryan leads Nordson's engineered shaft business unit. Ryan, let's talk about Nordson Medical. So first, can you, you're based in Brooklyn Park, and this is, kind of the core facility, right, for Nordson's engineering shaft and interventional products. Can you give us a quick overview of the complex engineering shaft capabilities there?
Yeah, absolutely. For those of you that don't know Nordson Medical, we do have 15 facilities located globally, really focused on design and development and integrating our component technologies into finished device solutions for our customers. Primarily focused on balloon catheters and complex engineered shafts. So we do have our Center of Excellence for Domestic Manufacturing located in Brooklyn Park, Minnesota, but we also have established development centers located globally to support these types of systems. Very recently, we've invested heavily in building out our quick turn capability specifically for complex engineered shafts. And we opened a new office in Louisville, Colorado to support exactly that, to respond to our customers' need for getting prototypes in hand quickly. Across all of our facilities that support these types of systems, we have all the necessary catheter manufacturing capabilities, from braiding to coiling to encapsulating laser cut hypo tubes, RF tipping, handle assembly, handle design, as well as all of the component capabilities to allow us to have kind of industry-leading vertical integration in this space. So we have capabilities for both film cast PTFE liners, ram extruded PTFE liners, FEP heat shrinks, thermoplastic extrusion. So really the full gambit of whatever's needed to be able to support complex engineered shaft and delivery system development and manufacturing.
Ryan, beyond the quick turn and kind of general overview, I wanted to talk about how Nordson capabilities and what you've done can really minimize R&D cycle times. Because development of complex shafts, I think typically multiple passes in terms of getting to a final design. How have you guys been using the Simshaft modeling, and what's the impact on prototyping?
Yeah, we use it very commonly, and especially in early stage development. If you're not familiar with our Simshaft offering, it's essentially a quantitative software package where it allows us to input certain design configurations of composite shafts, whether that be one layer for looking at how a single extrusion might operate, or multiple layers for how a composite shaft might function in terms of performance. So it's a great tool for kind of baselining and benchmarking a starting point for where we're looking at for development, and then allowing us to build up multiple iterations, making tweaks. Might be different coil patterns, different wires, different braid patterns, different number of starts for braid wires. Input all of those different variables and get kind of a computational output that gives us a directionally accurate starting point for jump starting development. So it's a very useful tool for helping to kind of down select if there's, our customers come to us with a list of design inputs. It allows us to help kind of narrow that funnel down from, a huge quantity of potential options and variables to be pulling at, and kind of guide the initial development in the right direction. So it's a very powerful tool for helping us to at least get the program started in the right direction. It is a computational software, so it doesn't have direct correlation to what your actual outputs will be for kink resistance or tensile strengths or compression resistance or torsional rigidity or any of those types of performance features, but it is very powerful for giving us a great starting point.
Can you talk about how this figures into, for instance, steerable design? Somebody comes in, is it sophisticated enough that it will help you actually reduce design cycles for steerable shafts?
Absolutely. Really, the way we can carve it up is we can chop each individual segment of the catheter into a standalone piece and look at how that will perform if we change different design features and play with those variables. So it's definitely very, very helpful in the complex shafts when we're trying to tackle complex problems. So yeah, we use it for anything from micro catheters to standard cardiovascular guide catheters to complex structural heart type applications. So there's really no limitations to where we can deploy the technology.
Fantastic. Please do follow up with us on anything specific. Again, you can either get a hold of us through the DSA website and just send us questions with what you need. Talk to you soon.